Hello, everyone. I hope you're all feeling fantastic. Root Beer here, looking at question number 5 on our Alberta High School Math Competition. A millennium number is a positive integer so that the product of its digits is 1000. The number of 6-digit millennium numbers is. Okay, so these are big numbers. We're probably not going to list them all out. But what can we do? Well, how do you make a product of 1000 using only digits? Now, digits have to be single numbers. So you have to use your ones, your twos, your threes, your fours, your fives. But think for a moment, am I going to use sevens or threes or nines? Now, if I've got 7 and then a bunch of other digits, I multiply them all together, I've got a multiple of 7. But I need the product of all these digits to be 1000? Well, 1000 isn't a multiple of 7, or 3, or 9, or 6. But it is, 1000 is 8 times 125. So there are some, factors of 2, there are some factors of 5 here. And in fact, you gotta have 3 5s in order to make this 125. And so that forces upon us 3 5s already. Now, I don't know where they are. If I imagine my 6-digit number, I don't know where these 5s should be. But I do know I'm going to have 3 5s. There's no other way to get factors of 5s here. Okay. So that just leaves us with, well, how do you make 8? And there are lots of ways to make 8. Let's try and make a little sort of chart or a general list here. So how can you make 8? Well, we're going to list biggest numbers first. That way we stay organized. You could have an 8, a 1, and a 1, right? So if you got an 8, that's sort of everything you need. Well, maybe we don't have an 8. Maybe the biggest power of 2 we've got is a 4. Well, you'll need a 2 somewhere in there. So 2, and then there's nothing else left, so a 1. Or maybe it's just a bunch of 2s. So there's 3 ways I can make the factor of 8 in my 1000. And then the rest is just all 5s. Okay. So I know the ingredients. I know what digits I might need or could use. But how do I arrange them? Because, of course, 555. Oh, sorry, I guess 558. My brain and my mouth are not talking to each other. Or my hand and my mouth aren't talking to each other. 558115 and 581515. They use the same sort of sets of digits, but they are different numbers. So, well, how the heck do we do this? What can we do? Okay, so here it sort of depends on how you're comfortable counting things. If you're someone who's familiar with multinomial notation, this isn't too bad to work with. Okay? If you're not as familiar with that, and if not, it's not the most important thing for contests, but it is a useful thing. Multinomial. You might want to look that up. I know in one of my first year university classes, we tend to teach multinomials as a way of counting. So, if you want to know about multinomials, that's fine. If not, we'll put it out of our minds and we'll try and count this another way. Okay. So what I want to do is I'm going to break it up into where the 5s go and where do the other numbers go. Okay, that's what we're going to do. So what I want to do is I've got 6 digits here, and I want to choose 3 of them to be my 5s. So, we'll designate this as a 5, this is a 5, and maybe this last one's a 5. That sort of a thing. Okay? And as soon as I choose those, I know exactly where the 5s go. And then we'll have to choose one of these 3 sets, and we'll put the numbers in their spots. Okay? So how many ways are there to choose where the 5s go? Okay? And you could try and list them all out. The first 3 are 5s, and then maybe it's the first 2, and then you leave a blank, and then 5s. And you can absolutely do that. I'm going to do this while I talk. Okay? But there is sort of a better way to do this, and it's similar to the multinomial work that we've seen before, or that I mentioned before, that you probably haven't seen, but you may have seen choose notation. You can see I'm slowly working my way through this. I am keeping organized, but it's going to take me a little while. Okay? That said, if you're writing this paper but you're not familiar with choose notation or binomial notation or how to handle a question like this, that's quite all right. There we go. Oh, sorry. That was all with just the 5 up front. I thought for a second I was done. Nope, now we can do 5s here. So now my first 5 is in the second position. Okay. But you can see this is certainly taking a while, and mathematicians in the past wanted to count things like this and noticed it took a while. So mathematicians in the past came up with better ways to do this. I just want to see how long it actually takes to write them all out. Feel free to jump ahead a little bit if you're not interested in watching me write out a bunch of 5s and blanks. But we are getting there. We're almost done. There we go, we did it. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20. It didn't take too long to write out, but remember, we are only on question number 5. We're not even done question number 5. And at least this would explain why everything I'm seeing here is a multiple of 20. We want to save time. Anything we can do to improve our speed gives us more chance to do questions 14, 15, 16. Now, maybe that's not your goal. Maybe you're just trying to practice the basics, and that's okay. But you got to admit, this took a while to write this out. So let me show you a faster way. As long as you're familiar with concepts like a factorial, you're good to go. So, very, very, very quick teaching lesson here. So n factorial is n times n minus 1 times n minus 2, and so on. So for all the way down to times 2 times 1. So for example, 5 factorial is 5 times 4 times 3 times 2 times 1. And this would be 120 if you actually bother to calculate it out. We're not interested in that. Now, if I give you 5 objects, maybe 5 letters, and I want to arrange them in an order, there's lots of different orders. How many different orders? Well, that's what factorial notation allows us to count. Okay? If you give me 5 different things, there's 5 factorial different ways to line them up. Okay. So how does that help us for our question? Well, I've got 6 digits to line up. Okay? Now, if I just had 6 different digits, 6 factorial, and we're done. No harm, no foul. But they aren't 6 different digits. I've got 3 of them are 5s, and 3 of them are these sort of blank spaces. Right? So, well, what can we do? Well, imagine all the 5s and the blanks were different. Okay, you got 6 factorial ways to arrange them. So maybe 5 number 1, 5 number 2, and 5 number 3, and blank number 1, blank number 2, blank number 3. But there are ways to get the same arrangements of 5s and blanks just from the level of 5s and blanks with, if you don't keep this distinction here. Now, how many ways are there to rearrange the 5s amongst themselves? Well, if the 5s were all different, it'd be 3 factorial. Okay? So we count each possible arrangement of the 5s 3 factorial, or 6, different ways. Well, we got to divide by that because you're counting the same thing multiple times. Same with these blanks. And so what you can do is you can get 6 times 5 times 4 times 3 times 2 times 1 all over. Well, what's 3 factorial? 3 times 2 times 1. 3 times 2 times 1. So those cancel out. The 6 and the 3 and the 2 and the 1 cancel out. And you're left with 5 times 4, 20. Oh, look at that. It's the same answer. Okay? This really does work. I'll leave it to you if you've never seen factorials. Choose notation is another way to write some of this stuff. Or binomials. This is similar to multinomials that I mentioned earlier. Okay. But this is how you would get 20. There are 20 ways to choose where your 5s go and therefore where the 3 other numbers go. All right, so we've got that. We've got 20 ways to pick where the 5s go. Now, once you've chosen where the 5s go, here's where it gets a bit more interesting. If I pick 8, 1, and 1, well, I've got 3 choices as to where that 8 goes. And then as soon as I place the 8, the 1s have to go elsewhere, right? The 1s have to fill in the remaining blanks. So if I've got 3 5s, an 8, and 2 1s, that's 60 ways to make a number, a 6-digit number. What if I have 4, 2, and 1? Well, again, if I've chosen where my 5s are going to go, and there are 20 ways to pick where the 5s go, there are 3 ways to pick where the 4 goes, 2 ways to pick where the 1 goes, and 1 way to pick where, 2 ways to pick where the 2 goes, and 1 way to pick where the 1 goes. It's actually 20 times, well, how many ways are there to arrange 1, 2, and 4 amongst themselves? 3 factorial. That's 20 times 3 times 2 times 1, so that's 20 times 6. That's 120. So far I've got 180 different ways to do this. Now, if I've just got 2s, as soon as I know where the 5s go, the 2s go in the remaining spots. So 20 ways to pick the 5s, and the 2s fill in the gaps. That's 20. So 60 plus 120 plus 20, that's going to be a total of 200. 200 ways to make these numbers. All right. Now that took a little while. Do remember, I took a little detour to try and explain counting problems like this. But, of course, you could have gotten the 20 by listing all these out. It didn't take super long. It wasn't completely unmanageable to do that. But definitely, if we could have just said internally to ourselves, oh, okay, I've got 6 things, 6 factorial ways to arrange them, but I've got 3 of them that are the same, so divide by 3 factorial, and then divide by another 3 factorial because the 3 blanks are the same, and get 20 that way. So much faster. And this is why, if you're serious about doing math contests, it can be useful to look into these things. I'll even write multinomials again. I erased it earlier. Okay. These are useful ways to count things up very quickly. Okay? So knowing them, you would have gotten that 20 much faster, and you would have just jumped right to this last page here. It would have been much faster. But what's our answer here? 200, so that's going to be E. And off we go. We're going to look at question at number 6 in the following video. So thank you guys so much for watching, and I'll see you next time.